video, we're going to learn to find terminators. Now, terminators are not easy to find at all, but I'm going to give you the simplest example. It's the one we use in class. So what I have here is a terminator as we defined it in class. This would be like the simplest one, the one that you can actually see with your naked eye, because it's all A's. You get some GC's in here, and then you get some T's. And that's obvious that there's a run of A's and a run of T's and a run of GC's. It's unlikely that you're going to get anything that looks even near this as your terminator. But since this is the one we know, and we can recognize it with our own eyes, we're going to use this one, and I'm going to show you how to find this one, and hopefully it will help you find a more difficult one. I will do at least one more video on finding terminators besides this one. This one is just like the simplest case, and the basic tools and the kind of order that you would have to go in to find terminators. So I have this, it's called Simple Terminator, and I have some sequence on either side that it's a little similar but not very similar. But of course this is very similar, and it's very structured. T's, A's, and GC's in the middle. This is all jumbled. Even though this is a little similar, some things are in the same places here, so that will add some I don't know, it won't make it 100% easy to find, because the thing is, if this piece is similar to this piece, it's going to confuse you with finding the similarities between here and making it stand out. So the thing is, I want to make sure you know how to make something stand out when you're looking for the terminator. So the first thing we do is, the easiest way to do this is to take your terminator sequence, take this one, and to find what's called the reverse complement. And I've already done that, but let me show you a tool on the internet that will let you find this much easier than having to write it down by hand, because the sequence is long. You don't really want to go and do the reverse complement all by yourself. So you go to this site. This is bioinformatics.org. So you can go search for it. Here, I'll go through it so that you can see exactly the order to find the site if you want to find it. It's a useful site. It does little things for you that a big program just doesn't bother to do. And you can just put in bioinformatics.org, or you could just go there and you go down to sequence manipulation. That's the one you want. And here are a bunch of tools, and the tool we want, now a lot of these things will help you in different things, and we could, Eugene does some of these, but a lot of these are just little tweaks like we're doing here to help you find things. So what we want is reverse complement. So sequence analysis, and we're looking for, here's reverse translate. We want reverse transcription though, actually what we want. We want the reverse complement. We want that one right there. And it has an example here to show you, and it uses amino acids and DNA to give you an example of what it can do. We're going to clear that, and what we're going to do is we're going to put our sequence in there. So I'm going to go back here, and I'm going to take our example sequence. We could upload it as a FASTA, but I'm just going to copy the sequence in here, and I'm going to put it right here, paste, and then I'm going to submit. Make sure it says reverse complement and not just reverse or complement. Alright, and then I'm going to submit this, and I'm going to get this, and it's in FASTA format. So all you have to do is grab this, copy, you don't take the top here, and put it and paste it into a file. And that's exactly what I've done here. I took that and I pasted it right here into a text file, and I saved it as termination example dash reverse complement. Whereas over here it's termination examples. So what I'm gonna do is I'm gonna take these. I'm gonna take the original FASTA, this one, and I'm gonna take the reverse complement, and we're gonna put it into Eugene. We're gonna go here to Eugene, and we're gonna go Tools, and we're gonna build a dot plot just like we've done before. And I'm gonna go find those two sequences. There, let's see, in desktop, fall 20. Oops, wrong class. And I have them down here. They are, where are they? My termination example. All right, and then get this crazy flickering with this recording software. Then termination example, reverse complement. So here I have the termination example and I have the reverse complement, and we're going to compare those two against one another. Now the trick to finding it is choosing your size. Now you're going to have some hints because I'm going to give you some papers that you're going to kind of know how long these terminators are. I'm going to throw in, because this one is kind of short, let's go back and look and see the size. How many letters do I put in here? I put in, how many A's? A's are 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many over here in T's? 1, 2, 3, 4, 5, 6, 7, 8. So 8 should be my number to put in because I have 8 here and 9 here. So these, there are going to be 8 of them that line up. So that's the number I want to put in to get good results. So I'm going to put 8 here. All right, I'm going to leave it at 100%. You probably want to lower it to about 90, or actually with 8 you'd have to go to 80. But because it's going to drop it. It's not going to make a difference if you don't go below whatever 1/8 is, and that's more than 10%. So you'd have to go lower than 90. Don't worry about that. Just realize 100. You probably should lower it lower than 100%. Maybe make it 90% if you have, say, over 10. If this is like 10 or 12 or 15, drop this to 90%. That'll help you. But you'll know what size because you'll know from some papers I give you, and I'm going to give another video on this once I've handed out the papers. But I want you to see this one in a smaller video so you just see what it looks like with a simple one that you understand. So we're going to leave it at 8 and 100%, and we're going to run it, and we're going to see what we get. Right there. There is your terminator. All right. Now you're probably not going to get this extra line. It's because A's and T's, they overlap and they're the same sequence, so you're getting this extra line. But this piece right in here in between, this is your terminator right here. It's actually not this long line. It's this. The long line is the one that's false. It's the two shorter lines. So, and then the region in between these two is your loop at the top. But this piece should line up in all A's, right? And this top piece should line up as all T's. Yes, all T's. So this is, and then of course the GCs will be in the middle. So this is how you would find a terminator if you had it as simple as the one we have. All right, this would be your method to find it, and you would find it every time if they were this simple. We're going to look and see how it might work with more complicated ones in another video.